Hello, everybody. Good morning. Thanks for joining us. We're going to give it just one more minute. People are still continuing to join, so we're just going to give it a couple seconds, and we're going to get started. Thank you. Okay. Thanks for joining us. We're going to get started now. Welcome to our comprehensive guide to ANSI Z358.1 and for emergency equipment. My name is Justin Dunn. We're going to get started right now. It's nice to see how many of you have decided to join us this morning. Thank you very much for attending our webinar. We really appreciate it. To get started, be sure to post questions at any time during the presentation using the questions section on that's on your control panel there. There will be a live Q&A immediately after we're done with the information in the webinar. Everybody's currently muted, so be sure to use that control panel. Submit those questions. I'll get to as many as I possibly can there at the end. And there will be a follow-up email after the webinar to ensure that we are giving you the recorded webinar. It's on demand on YouTube if you need the information afterwards. Otherwise, we're going to send you that link as well as the poll questions with answers to everything that was asked during the webinar. So we're not actually missing out on anybody's questions, but I'll get to as many live as I possibly can. Also, I'll bribe you to do it. So there's a follow-up survey that's going to be sent after the webinar, and we'll give you a $5 Starbucks gift card for your participation. So thank you for that ahead of time. My name is Justin Dunn. I'm the Sales Product Specialist / Trainer for Haws. I've been here about 5 years, specialize in educating on the ANSI standard, emergency equipment placement, use, and things like that. With me is Nicole Dennison. She's across the desk from me, helping me host this webinar. She is our marketing manager here at Haws. Today's topics are going to include what is the ANSI ISCA Z358.1 standard? I'll go over everything, the significant requirements of the standard, and how to test for many of those standards. ADA for emergency equipment. I'm going to briefly touch on the subject. I'm not going to go over it in depth. Many requirements for the ADA mirror ANSI. The original ADA standard was actually derived from an ANSI standard, so. Best practices for emergency equipment, and then the live Q&A there at the end. Now, OSHA is the Occupational Safety and Health Administration and is the agency responsible for regulating emergency shower and eyewash facilities. If you weren't already familiar with them, most of you should be if you're attending this webinar. The OSHA standard is 29 CFR 1910.151C. It's under medical services and first aid. And what it states is that where the eyes or body of any person may be exposed to injurious corrosive materials, suitable facilities for quick drenching or flushing of the eyes and body shall be provided within the work area for immediate emergency use, which is great. But that doesn't tell me how to accomplish this. And that's where ANSI comes in. ANSI is the guidelines that OSHA references to ensure that we are complying with 29 CFR 1910.151C. The primary use and of the ANSI standard is helping to prevent injuries and fatalities, generally lowering workplace risk, also preventing lost time and money for the employee and for the employer. There are a lot of expensive lawsuits, OSHA fines, not to mention the employee's personal cost. When you're injured by corrosive materials and you don't receive proper first aid, it can greatly extend your visit in a hospital and your first aid care to get you back up and working. It can take quite a bit of time. So immediate first aid response and appropriate response is important for both the employer and for the employer to help prevent those costs. Now, OSHA has stepped up enforcement, particularly for employers who have a history of serious or repeated violations. Obviously, those are the most serious of OSHA violations. We told you to fix something, you've ignored us, we're back, and now you're going to face some pretty serious fines. On August 1st, 2016, OSHA fines increased for the first time since 1990, and that was by 80%. There was no increase before that time, and 80% is a pretty scary number considering the size of some of the OSHA fines that we've seen. Effective January 2nd, 2018, OSHA fines have increased by an additional 2% to account for inflation. Now, this is all public information. We're not outing any companies here. This is all available online. Just going to point out a couple real quick, just to give everybody some general examples of non-compliance, the kind of penalties we're seeing for these. The larger numbers are, again, those repeated violations. The elephant on the page is up in the top right-hand corner, nearly $400,000, $382,605 to be exact. Failure to provide adequate eyewashes for employees exposed to hazardous substances. Another one's over on the left here. This is just a gym. They were probably working with a pool. Employees were working with extreme pH chemicals and were not provided approved eyewashes or a shower station. And very likely they were just probably treating a pool, hot tub, sauna, anything like that, and nearly $200,000 in penalties. Obviously, there are lower penalties on the page, $5,000, $6,000 for a lot of the same things, but these are probably very frequently non-repeated type violations. Now, the ANSI ISEA Z358.1-2014 standard was written by the ISEA, the International Safety Equipment Association. It was adopted by ANSI, and that standard defines emergency eyewash and shower design, location, and the temperature requirements for proper functionality and usage. Again, OSHA just references the ANSI standard for compliance. They never officially adopted the standard. They have their own standard, that 1910.151C, but anytime they fine for a particular non-compliance, they are referencing the ANSI standard in that fine. Now, the standard was first published in 1981. It was revised in 1990, 98, 2004, 2009, and 2014. In 2009, the primary revision changes were a temperature range for water delivery, simultaneous use, and then eyewash testing requirements. In 2014, the major changes included a design, manufacture, and installation of emergency showers, which were primarily concerns for manufacturers of emergency equipment. But we at Haws, we were well ahead of the change. We didn't have to make any changes to our equipment. We're already compliant with that. Equipment installation location, which was incredibly important, having that additional insight into where the equipment should be, how far it should be. I'll go over all of that. And then adjusted measurements based on the eyewash or safety shower streams, the water that's coming out, their placement, height, and things like that. Okay, we are ready for poll question number 1. We're going to launch poll questions throughout the presentation. We really greatly appreciate your participation in these. I think there's only 4 total, but these help us to continue to improve this product. So Nicole, if you would launch poll question number 1, please.
All right. Poll question number 1, which best describes your role in choosing showers and eye face washes? We'll give you just a few more seconds to wrap up your answers. All right. Thanks a lot.
Okay, continuing, we are going to get into the significant requirements and how to test for these. First of all, there is a weekly minimum performance requirement. These pieces of equipment have to be tested on a weekly basis. There are very important reasons for a weekly test. One of the most dangerous of those being things like Legionella, bacteria in the pipe that can cause other issues if the pipe and the dead leg in that piping isn't getting cleared out on a regular basis. Not to mention potentially not discovering performance issues with the equipment if somebody is doing a high-risk task, and ensuring that we are compliant and that first aid emergency equipment is ready to go if somebody is harmed by a dangerous substance. Now, a lot of facilities they're not doing weekly testing. We need to be doing weekly testing. I find very frequently that it's not very frequently being done, or sometimes the maintenance team on site is struggling to keep up with it because they have other responsibilities. But the testing itself is very simple. It's very fast. All that needs to be done is you need to visit the equipment, activate the equipment to ensure that you have water flow to the heads of the device, and then ensure that that duration of activation is long enough to clear out all the stagnant water in the dead leg and the piping. That way it's not sitting there, bacteria is growing, sediment is building up, and potentially helping to prevent rusting and things like that in the piping too. So that water needs to be moving. Otherwise, they're going to get a face full of some pretty nasty water as soon as they activate that equipment. An annual inspection is also required. The annual inspection differs from the weekly activation in that it is a full head-to-toe test of the emergency equipment. This is also incredibly important, but can be difficult to do for some facilities. This is a full 15-minute performance test of the equipment. So the shower needs to be activated, eye wash or eye face wash activated. All the measurements need to be made that I'm about to go over. And we need to ensure that it's meeting the minimum performance requirements for the amount of water that's pumping out of the equipment. So all the requirements that I'm about to go over are going to be required in this annual inspection. Some of the tools that you're going to need, this is our 9011 test kit, and provides you with all of those tools. And the things that you're going to want to focus on are, one is a tape measure. We want and need something to measure the height of the water, the shower head, the pull rod, all of those things. The Eyewash gauge, this was a gauge that was designed and given to us by the ANSI standard. I'll go over it a little bit later. 5-gallon bucket with the 2-gallon water line marked. It's basically like checking your pulse, right? The nurse isn't going to sit there and count your pulse for a full minute. We're not doing that. We're doing the same thing. We need to meet 20 gallons for the shower in 60 seconds, and we're just going to take a sample of that and do the math. You're going to need the shower sock and pole to help capture all of that water. Make sure you hold it nice and sturdy. There's 20 to 30 gallons coming out of that shower, and don't wear your nice shoes. Thermometer, very important. We need to check the temperature of that water, ensure that we're within 60 to 100 degrees Fahrenheit. And then last, an ANSI Z358.1 checklist. We make a really great one. I would highly suggest, it's free on our website if you need just the checklist. I would highly suggest going on there, downloading it. I think we'll probably provide it in the follow-up email. I'm getting a nod from Nicole. It's fantastic. We'll send it to you. It's an incredibly useful document. You can copy it, send it to anybody you'd like, and utilize it in your facilities. It's really a great tool. Okay, to get started, number one, the equipment needs to be accessible within 10 seconds from the hazard. Now there's an addendum to the ANSI standard At the end of the standard, it gives us the requirement for 55 feet. 10 seconds was originally kind of a confusing requirement. All of us can travel 10 seconds in a different amount of time, and it can be difficult for us to gauge an exact distance based on 10 seconds. So they gave us a measurement of 55 feet. So 55 feet is the maximum distance that the equipment can be from the hazard. There is nothing in no type of equipment that can be in place. A lot of people ask about supplemental bottles and stuff like that, the little squeeze bottles you put in place at the hazard. Nothing extends that distance. And of course, the closer we place that equipment to the hazard, the better. We want that as close as possible, given that it's safe to do so. There are some areas where you have to evacuate the room. You have to get out of the containment spill area to receive first aid, and there's nothing you can do about that. Still needs to be within 55 feet, but again, just try to get it as close as possible. We want first aid as fast as possible. Seconds count when you're dealing with corrosives, caustics, and things like that. To test this, again, just measure 55 feet, check for the proximity to the hazard on the emergency equipment. It needs to be located on the exact same level as the hazard. There's an example on the right-hand side there. Stairs, berms, curbs, things like that are things we want to try to avoid. We cannot have any stairs between the hazard and the emergency equipment. You probably already don't have very good use of your eyesight, given a chemical spray or something like that. So we need to ensure that we're not creating an obstacle course between the hazard and the emergency equipment. Ramps are an easy way to they're kind of a gray area. That's an easy way to get around this requirement and to make that pathway as safe as possible. If you do have a change in level, try to use a ramp, something that's gradual, that's not going to catch somebody off guard, cause them to trip, or lengthen the time that it's going to take them to get from exposure to first aid. The area needs to be free of obstructions. Emergency equipment is especially safety showers and first aid, eye washes, eye face washes. It's kind of a weird piece of equipment. You have to have it. We want you to buy it. It goes in the corner of your facility and it gets neglected. It gets forgotten. We don't ever want you to have to use it. If you're using a piece of emergency equipment, you're probably having one of the worst days of your life. And tool carts and garbage cans and hoses, as you can see over on the right side of this photo here, things just get stacked up in front of these or on them. I've seen some terrible situations, and we have to make sure it's completely free of obstructions. We don't want people having to remove it or unbury the piece of equipment just to get first aid. Moving on, the area needs to be well lit, and it must have easily identifiable, highly visible signage. Okay, so on the right here we have an example. We have a combination unit. It's a little bit faded. It's probably in an outdoor situation, but I don't have any signs on the equipment telling or informing somebody that there's a first aid piece of emergency equipment over here. So check for proper signage. Make sure the area is well lit. I prefer to tell people to go to the hazard and try to identify from that position where the closest piece of emergency equipment is, and ensure that that signage, try to make it up high too if you can, is as highly visible as possible so they can navigate there as quick as possible. It has to deliver flushing fluid for a full 15 minutes. Now 15 minutes is a bare minimum when it comes to eye washes and safety showers. There are chemicals out there, specifically corrosives, that require much longer than 15 minutes, sometimes 30. The highest I've seen is 60 whole minutes that is required in the SDS sheet, the safety data sheet, for first aid measures for a safety shower. And that's because some of these chemicals are, again, highly dangerous, not easy to remove from your body. And even when first responders arrive on scene to assist you, they are going to ensure that you have finished your 15 minutes, 30 minutes, 60 minutes, whatever was required before they start to handle you. Otherwise, they risk the potential to start exposing themselves. And if they remove you from that equipment too soon, and you're on the way to the hospital and you still have these chemicals on you, it's going to make a bad situation even worse. So run each piece of equipment for a full 15 minutes. We want to ensure, and that's just on the annual test, but we want to ensure that it has the capabilities to run for that full 15 minutes. If it's a portable or self-contained type of equipment, when you're changing out the water and servicing the unit, just run it for the full 15 minutes. Let it drain and test it that way, rather than doing an annual in between the servicing on a self-contained tank type of equipment. Now, all the outlets need to be protected from airborne contaminants. All this means is that the dust covers have to be in place. So ensure all the heads of the devices, stored flushing fluid, everything is covered and protected from dust and debris in the area. If there's a process in particular in the area, so there's wood shavings or plastic shavings, cement, even all kinds of different stuff in the air and flying around, we want to make sure that the outlets are covered so they don't get clogged or clocked. I just mixed both of those words up, clogged or blocked, and ensure that it's not going to affect the equipment. Now, the dust covers have to be self-removing. They have to activate with the unit. So as soon as you activate the equipment and the water, the dust cover must come off all by itself. You cannot use your hands to remove the dust cover. This is non-compliant. The strangest thing I think I've seen so far is shower caps. I saw somebody using shower caps as a dust cover in their facility. You cannot do that. When you activate the equipment, dust cover has to come off by itself. Now, the equipment needs to go from off to on in 1 second or less, and it needs to remain on without the use of the operator's hands. To evaluate this, just activate the equipment, ensure you have water flow immediately to the heads of the device, and there is no delay there when you activate the equipment. This can mean that there's potential blockage in the pipe, and that it's going to activate immediately when the victim goes to receive first aid. Now, there are minimum requirements for the flow rates for each piece of equipment. There is an Eyewash, face wash, and drench shower requirement. On the Eyewash, it must deliver a minimum of 0.4 gallons per minute, 1.5 liters for my friends up north. This isn't a lot of water. You only have the 2 streams of water coming out of the device, one for each eye. On an face wash, we have 3 gallons per minute, or 11.4 liters. That's because this is covering your eyes, your forehead, and your lower face, your cheeks, mouth, and things like that. The drench shower has to have a minimum of 20 gallons per minute, or 75.7 liters. All of these are bare minimums in the ANSI standard. There are no maximum flow rates for the equipment. So we run into a lot of situations, many competitors that end up utilizing just a ton of water out of their shower heads in particular, and can create some pretty dangerous situations in which they starve the Eyewash or face wash. So make sure you're utilizing flow controls in your system to help prevent starvation there. And we can test all of this by using either the Eyewash gauge or the 9011 test kit, again, the bucket with the 2-gallon water line marked. The equipment needs to provide a controlled flow of flushing fluid at a velocity that is low enough to be non-injurious to the user. Now, this is so important. I call these brain washers. Eyewashes that have way too much pressure to them. You flip that paddle and all of a sudden you have a spray pattern that's shooting like 20 feet one way and 20 feet the other way, and nobody's going to be able to use that for 15 minutes. It's going to hurt really bad to use, and may potentially injure you even more. The shower is another issue. 15 minutes under 30 to 40 gallons per minute is not going to feel great. You're already potentially losing the outer layer of insulation on your body, your skin, and to have that much water pouring down on you for that amount of time is going to hurt. So again, flow controls, ensure that you're controlling the water. It's a gentle flushing experience for the victim. We want this to be a comfortable as possible of an experience for the victim. We don't need to make this harder on them. So just confirm by ensuring the flow rate from the shower and eye wash and the pattern. And I have tools for you to do that. So this, again, I mentioned this earlier, this is our eye wash gauge. This was given to us by the ANSI standard. That's their drawing on the right-hand side there. And what they said, their requirement was that the flushing fluid needs to cover the areas between the interior and exterior of a gauge at some point less than 8 inches above the eye wash nozzle. Now what this means is you take a tape measure, you go to the head of the device, the eye wash or eye face wash, measure up 8 inches, and then slowly lower the eye wash gauge to ensure that the streams from the eye wash are meeting the gauge. This is telling us that it's usable. This is going to meet the human eyes. And that's what this eye wash gauge is based on. It's based on average human eye spacing or anthropometrics. So utilize the gauge. As long as it's meeting it, we can assume that the equipment is meeting the minimum flow rates and that it's usable and compliant. So this is what happens when you have too much and too little as far as flow rate goes. On the left, that's an eye face wash with 3 GPM. There's way too much water plumbed to that thing. There's no flow controls in place, and that is going to feel absolutely terrible if you put your face in that. It's going to hurt, and you have to do this for 15 minutes. There's just no way. Too little flow, and we get the situation on the right-hand side. So 0.4 GPM, this is not meeting that requirement. There's not enough water here, and when we get into these situations, I mean, looking at this picture, you're going to have to choose right eye or left eye. Which one's your favorite? Which one do you want to save? We want to make sure that we're not forcing people into that situation, or at worst case, there's nothing coming out of the equipment. There's no water at all. Both incredibly dangerous situations we want to avoid. Here we go. Here's a great illustration video of how to use the gauge. Tape measures the 8 inches. The gauge starts there. He's slowly lowering it, and the streams from the eye wash are meeting the eye circles on the gauge. Now, there is equipment out there where lowering the gauge to 0 inches, some of you might have questions. I mean, how far down do I go? Go all the way down. So long as those streams are meeting the gauge, it is compliant. There is equipment out there that have some pretty strange, pretty interesting designs. First one that comes to mind is the Speakman. They have I call it the ear wash, but it has 2 blades on either side. It shoots water towards the middle, and the gauge would align at 0 inches, right in between the blades, and wash your face and your eyes. So there is equipment out there where that is would be a compliant situation. So make sure you go all the way down to ensure that it's lining up. Okay, so again, here's a better view of the test, so you can see the eye wash streams meeting the eye circles on the gauge. It's less than 8 inches. The reason why we have that 8-inch measurement is because above that, we don't want people doing a balancing act. If it's too high, we want people to be able to hold on to the bowl, balance their head and their face, align it with the eye wash streams, and easily have to sit there for 15 minutes. We don't want to make this any more difficult for them, and it's easier to do if you're stooped over the bowl, balancing on it, and your face can stay still. If you have to balance your face 16 inches or 2 feet above the eye wash nozzle, it's going to be a little bit more difficult, and it's not going to hit your eyes correctly. Now, the flushing fluid flow pattern cannot be less than 33 inches from the floor line that the victim is standing on, and cannot be greater than 53 inches from that surface either. This was previously a measurement of 45 inches that was measured to the head of the device, and that wasn't doing us any good. That didn't tell us anything. So we got 33 to 53 inches for the top of the water, the flow pattern coming from the device. And what this is doing is ensuring that we're not getting injurious flow patterns out of the equipment. So if it's spraying too high, which is not a stretch, 53 inches, it's not that tall, you'd be surprised how much equipment you throw it on and it's exceeding 53 inches. That is injurious, and we need to do our best to prevent that. So Injurious flow rates below 33 inches. I run a survey program here at Haws. I've never seen equipment with a flow pattern that is less than 33 inches. It's probably out there somewhere. I've seen some crazy stuff. But generally, I focus on 53 inches. It's if it's controlled, you have flow controls in place, and it's a gentle pattern of water, it'll be under 53 inches. Over 53 inches is a great mark, ensuring that we're not getting that injurious flow. There's also another requirement included in this section, and it includes a minimum distance that the heads of the device have to be from any obstruction, and that's 6 inches. So measure 6 inches around the heads of the device, and we're just making sure that when you go to use it, there's nothing that you're going to hit your head on, basically. There's nothing that's going to hit your head, and there's nothing obstructing the flow pattern of water out of the device. Here we go. So use the tape measure. Determine the height of the flow pattern. You're measuring from the head or from the floor line up to the top of the water stream. So, and you're just going to use that tape measure to measure from the floor line and up. Here on the right, we have a piece of equipment. There is not enough water plumbed to this thing. And which unfortunately is really common. It could be another process in the facility that's starving the water to the equipment. So dedicated lines are really important, or it could be obstructions, blockages, I said it right that time, in the pipeline, preventing the water from reaching its max potential, or plumbing too small of a feed line to the equipment. 1.25 inches is the minimum size for emergency equipment. So we want to see 1.25 inch pipe plumbed to a combination unit to ensure that it's compliant. So a shower head, remember, shower has to pump out 20 GPM. For combinations of equipment, we're looking at shower and eye wash, 20.4 GPM, and then shower and eye face wash, because it's using more water, we're looking at 23 GPM, bare minimum. So the flow rates for the shower head, what you're going to need to test that flow rate is that 5-gallon bucket with the 2-gallon water line marked, the shower sock and pole like you see on the right, and the thermometer, just leave it in the bucket. If you're not testing the shower and you don't have the bucket, you're going to fill it up. Leave the thermometer in the eye wash bowl or just under the stream for a couple minutes, and you'll get that temperature reading. Or if you really want to upgrade, those laser thermometer, those are awesome. Those work really well too. So to test this, place the thermometer in the bucket, place the shower sock around the shower head, hold firmly, and put the bottom into the bucket. Activate the shower for 6 seconds. That's all we're going to do. 1 Mississippi, 2 Mississippi, all the way up to 6, and then check that the 2-gallon water level mark on the bucket is met. And what we're doing is, again, this 2 gallons, 6 seconds, times 10, 20 gallons, 60 seconds. And we're just making sure that we're getting that minimum amount of water out of the shower. At the same time, remember that the eye wash or eye face wash, to test those requirements over the water flow out of those, you're just using the eye wash gauge. So long as it is aligning and hitting these eye circles on those, it's compliant and it's meeting the correct amount of water. The shower flow pattern has its own requirements. Now, it's obviously difficult to test this with the shower sock and the pole in place. You're not going to be able to see the flow pattern. But the shower has to provide 20 inches wide at 60 inches above the floor of the surface user of the victim. And that's to make sure that it's meeting, again, average human anthropometrics. So shoulder to shoulder, if you're standing upright in that stream of water, it's covering your entire body. And that's what we want to focus on. The center of that column also has to be free of obstructions by 16 inches in any direction. So 32 inches total, but 16 inches in any direction from the center of the column. We don't want that flow pattern obstructed in any way, and ensure that you can fit correctly into that space. On the right, you can see a compliant versus non-compliant version. On the right, looks like we just don't have enough water here, and isn't going to cover your body correctly. To measure this, this is very easily done outdoors. If you are indoors, I do this as fast as possible. It's a little more difficult to accomplish this. If the shower head itself is not damaged, it's in great shape, and you met the minimum amount of water using the bucket test, then it's pretty easy to assume that the shower head was designed correctly and it is putting out the correct flow pattern for compliance. Now, if you're outdoors or if you're in an area that you can easily clean up, just remove the shower sock, turn on the shower, take a step back and measure just like in the video. That's not terribly hard to do. That's the easiest way to do it. But if you're in an area, again, with sensitive equipment, leave the shower sock in place and just ensure that the shower head itself is in great condition and it's not damaged, and you should be just fine. The shower head, the outlet of the water, must be 82 to 96 inches above the surface floor of the user. You can just use the tape measure from the floor up to the outlet of the water. This is making sure that if the shower head's too low, we're not going to get the correct spray pattern. It's not going to cover our entire body at once. If it's too high, we also risk not rinsing our bodies correctly. The spray pattern will be too wide. You're not getting enough water focused on your body and will not remove the contaminants like it's supposed to. So 82 to 96 inches, very important. Make sure it's within that range. The pull rod also must not exceed a maximum height of 69 inches from the surface floor of the user. And that's measured from the surface floor to the very bottom of the pull rod, the part that you're going to grab. And this makes sense because the taller amongst us, I'm like, well, I lie. On my driver's license, it says 6 foot. I'm 5'11". I just do it to make myself feel better. But if the taller amongst us can grab that pull rod at any height, it doesn't matter, right? The shorter amongst us, we want to make sure that it does not exceed 69 inches to ensure that they are able to reach up and grab the pull rod and activate it easily. There is, of course, other pull rods out there that are longer if you have somebody that needs that assistance for ADA purposes, ensuring that it's within the reach ranges for accessible design and wheelchair accessibility. Otherwise, they usually sit just a little bit below that 69-inch requirement. Now, combination unit components shall be capable of operating simultaneously and be positioned so that the components may be used simultaneously by the same user. Now, this is, I briefly mentioned this earlier, but if we are not careful and if we are not using flow controls on this equipment, we can get into a really dangerous situation, and that dangerous situation is simultaneous flow. And what happens if you'll go to the equipment, you'll activate the Eyewash, you'll activate the eye face wash, everything is working great, things are going well, but you activate that shower and it is utilizing too much water. There's no flow control. They're regulating the water, pushing it back down to the Eyewash or eye face wash so that it can function correctly, and it will dump everything that is plumbed to it, starving the Eyewash or the eye face wash and causing a really dangerous situation. And now you're choosing between saving your eyes or saving your skin, and if only one is going to work at the time. So both pieces of equipment have to operate at the same exact time. And we have to ensure that there's no starvation. Now the components, for whatever reason, I have no idea, they throw the instructions away the second they get it. Sometimes the plumber, the contractor, I find them all the time, will think that the shower is for one situation and the eye wash or eye face wash is for another situation, and they will face them pointing in opposite directions. But this equipment is designed to be used at the same exact time. It's full body decontamination. So ensure that the shower head is directly over the eye wash or the eye face wash. We don't want them pointing in different directions. Just like it's in the picture, where the shower focused on the back, eye face wash focused on the face and eyes, and we are decontaminating ourselves. So just ensure they're lined up and test the equipment at the same time. Usually I leave the eye wash or the eye face wash on when I do the shower bucket, shower sock test for the shower, and just keep an eye on the eye wash or eye face wash when you activate the shower. And while you're counting to that 6 seconds to ensure that there's no dip in performance to that equipment. Shutoff valves are not very frequently talked about in the ANSI standard. Something, I don't know, for whatever reason, it's kind of glossed over. Shutoff valves are a necessity for emergency equipment. They have to be in line, right? There's eventually going to be maintenance, or they may have some other process that's tied up on that particular water line that they have to shut that off to do, again, other maintenance downline. But shutoff valves, if they are not locked open and only and access to that only given to authorized personnel, any employee can just walk by and shut the shower off. I run into it all the time at facilities where I activate the equipment, nothing's coming out, and we find out that the valve upstream is just, it's off. We throw it right back on, everything comes back into service, and it's working correctly. So a lotto device, or a lot of valves themselves have a locking mechanism on them, has to be locked open. So we don't have any accidental issues with the equipment being turned off by employees who are not authorized to do so. Now the equipment needs to deliver tepid flushing fluid between 60 degrees Fahrenheit and 100 degrees Fahrenheit. We've been doing this for a while now. This is, again, not with the 2014 standard, but the 2009. So the technology that is required to do this in some facilities, some of you are very lucky and you're in that like golden area in the US where you only get like 1 month out of the year where, you know, temperatures get real chilly in the water. But the technology now has advanced so much from where we started. It is much easier now to instantaneously heat the water on a high GPM level for this type of emergency equipment. There's the instantaneous heaters designed specifically for emergency equipment. We sell them, and they're very important for this type of application. Now, also make sure that when you're testing the temperature for this equipment, and if you're doing it on a quarterly basis or something like that, make sure you're testing during the colder months. If it's just an eyewash, leave it on for a couple minutes. See if you exhaust the warm water inside of the walls of your facility and start pulling cold groundwater, things like that. Think outside of the box when testing for 60 degrees to 100 degrees Fahrenheit water. There may be process heat at a certain point in your facility that will reach that piece of equipment if you leave it on long enough. So during that annual test at the beginning, test in the middle, and then test at the end of that test to ensure that you're achieving tepid flushing fluid throughout the entire 15 minutes. Now, having that 60 to 100 degrees Fahrenheit is going to do a couple things for us. Number one, 75% of ophthalmologists say that having tempered water is very important, citing that it increases the chance that a victim can tolerate the 15-minute flush required. And I've heard some pretty awful stories of coworkers having to force their fellow coworkers into the equipment because it's too cold or it's just too hot, but whatever they're dealing with on their skin is so much more dangerous than having to worry about hot or cold water. So if it's too cold, if it's too hot, it may force them to finish that 15-minute flush way sooner than they should. And it's going to help encourage the victim to remove their clothing, because you got to be in your birthday suit. You got to get all the way undressed. Make sure you're in that equipment. The clothing can trap the contaminants between your skin and the clothing and cause even more damage. So it has to be removed during this process. Now, tepid water is really easy to test. On this one, we have a different device, but again, a laser or any kind of thermometer, test that water, check the temperature, and do so at different times of the year and different intervals during that 15-minute test to ensure compliance. I just throw the thermometer in the bottom of the 5-gallon bucket and I test it that way, and then let it run for a little bit and I'll retest it. Now, I call this the no-duh clause in the ANSI standard. Employees who may be exposed to hazardous materials shall be instructed in the location and the proper use of emergency equipment. Employees have to understand how to activate this equipment and how to utilize it. Now, when you think of a piece of emergency equipment, typically you think, okay, push paddle, pull rod, that's how you turn it on. But there are manufacturers out there who have deviated from those standard ways of activating emergency equipment. So make sure that those employees or you understand how the emergency equipment in that area works. And if they work there frequently, do a quick training with them. Ask them questions, make sure they understand how it works so that they're not guessing when they get to the equipment. You know, we don't want them to expect a push paddle and find that you have to lift the lid or unlock a pin, which would be non-compliant also, by the way. But we don't want them to have to guess. Check for the need for freeze protection. It's like clockwork. January, February, March, as we start getting into warmer months around the US in certain areas, we start seeing a huge uptick of valves for the shower and for the eyewash that have frozen and ruptured, and they need to replace them to get this equipment back up to speed. And that's because they're not freeze protecting that equipment for the colder months. It may only be a couple weeks out of the year, it could be a couple months, but there are ways to prevent that. Insulating the pipe, using heat trace. The unit on the right-hand side here, this is an 8317 CTFP cable trace freeze protected equipment. It has heat trace all throughout the shower to prevent freezing, and is active when the thermostat tells it that or a thermometer tells it that it's below a certain temperature. It'll start protecting the piping. It doesn't temper the water. You have to do that back before the emergency equipment, but it will prevent any freezing of the equipment. You can also use Berry valves. There are all kinds of ways to prevent freezing of the equipment. One installation consideration. So very early on in the webinar, I mentioned that there can be no change in level, right? So a single step is allowed in the ANSI standard, but it must be into an enclosed piece of equipment. So like you see on the right-hand side here, this is an enclosed Haws integrated piece of equipment. We cannot make this, or any manufacturer, we cannot make this flush with the ground without the bottom sealed as a full compartment. Because what that piece of equipment is for extreme environments, hot or cold. So the compartment inside is holding heat, or it's being air conditioned to make sure that if we are in an offshore oil rig in Alaska, that the person that is having the first aid emergency inside of the equipment is staying warm. They're having a comfortable experience. They're not experiencing a wind chill factor, hypothermia, and cardiac arrest, all that type of stuff that happens when our body loses heat too fast. So it must be a sealed compartment. So you are allowed to have a single step, one single step into an enclosure, and that's it. Where there is no enclosure, if it's just a standard piece of equipment, you are not allowed to have a step in between the hazard and the equipment. I always get that question after the webinar. There is also in Appendix B5 in the ANSI standard, there is an installation consideration for a door, one door. It has to meet certain requirements though for it to be in place. Number one, the door has to be non-locking. We wouldn't want somebody accidentally locking the door or thinking somebody was done with the process, locking it, walking away, and somebody not being able to unlock it to get to emergency equipment. The doors also have to open in the direction of the emergency equipment. So as you are moving, very likely running from the hazard where you were exposed to the emergency equipment, you have to be able to open the door outward, away from you, so as not to have to stop, grab a handle, pull, and waste valuable time. The hazard also has to be non-corrosive. And this is because obviously you have to get to that emergency equipment as fast as possible. We cannot be worrying about doors and obstructions in place. So if it is corrosive, then you cannot have doors in place. The doors also have to be push bar or panic bar operated. So you have to be able to, as again, you're moving and the doors opening away from you, you have to be able to push the doors open and activate it that way. So as long as it meets those certain qualifications, you are allowed to have one door or something similar to the photo over here in place. Okay, now poll question number 2. Again, we really greatly appreciate your participation. Nicole, if you'd launch that, please.
Okay. All right, so hearing the presentation today, what are you likely to do after today's webinar? And please check all that apply. And if any of this does not apply, please just don't answer the question. Okay, all right. Thank you for voting. I'll give you just a couple more seconds and then we'll wrap it up. All right, back to you, Justin.
Okay, so I talk a lot, and we're getting closer to that hour period. I don't want to take too much of your time up, and I want to make sure I get to the Q&A section. So we're going to move through the next section pretty quickly. I really just I threw this in there because I talk about it a lot. It's ADA for emergency equipment. I get a lot of questions about it because there is nothing in the ADA specifically calling out emergency equipment, but the other half of our business is drinking fountains, and elements of a facility, drinking fountains, baby changing tables, sinks, toilets, fire extinguishers, all of those things are classified as an element, and they all have to meet the same requirements for accessibility. So real quick, I was just going to cover a couple quick things on this particular topic. ANSI requires 6 inches minimum clearance from any obstruction. So we have to make sure in line with the ADA that we're meeting our ANSI requirements too. So in this particular example, I threw in the 7610. This is a long arm behind the sink pull down activation piece of equipment. Okay. Now, for the ADA, for emergency equipment, combination units, eye face washes, eye washes, showers, even that deck mounted unit I just mentioned, you have to have clear floor space, 30 by 48 inches, 32 inches for California, in front of the equipment to allow access for that wheelchair. This is a little bit larger than your average measurements for a wheelchair, and that's to accommodate your hands on the side of the wheelchair and a bit of maneuverability. Now, the reach range is very important to remember when it comes to activation of emergency equipment, whether it's a pull rod or, again, a piece of equipment on a countertop or deck. We have to make sure that it falls within our reach ranges. Now, unobstructed, we're not going to worry about it. It's going to be generally obstructed. We do have one piece of equipment that is fantastic. It's an in-wall mounted, it has a handle on the wall, and you pull it down. It's a tray, extends out over your legs, and is ADA compliant for an eye face wash and shower. And that would be a great example for unobstructed. But your reach range is 15 inches to 48 inches if it is completely unobstructed. You're between you and the wall or the device. Obstructed, you're on the first example, the equipment must not extend out between 20 inches. If it does, obviously you lose your low reach range. Your high reach range is a maximum of 48 inches, and that's why we design a specific pull rod that is much longer to make activation for this type of equipment easier for ADA accessibility. Now, if the equipment extends 20 to 25 inches, obviously the reach range goes down to 44 inches. You're having something pressed against your body, you're reaching over something further, and to make it a little easier, we have to lower that range. Again, 30 by 48 inches, again, 32 inches for California. And the reason why this measurement is so important is to ensure that when you're underneath the shower that you have, it is completely unobstructed, and that shower flow pattern is going to meet your whole body. We have to make sure that that clear ground space is there so that you can easily maneuver underneath the shower and up to the eye face wash. Here's the example of the unit I just mentioned. This is the 8356 WCC WCW. These are in-wall mounted eye face washes with showers to 100% ensure ADA compliance. These are absolutely fantastic. If you need this type of equipment in your facility, this is the way to go. We also have combo units, standalone ones that are available, and some other options for deck mounted and stuff like that. When you're dealing with a deck or counter though, make sure that underneath you have toe and knee clearance. That's 27 inches and 9 inches of toe clearance to make sure that you're able to approach emergency equipment at a countertop. Here's a great example. Here's that in-wall unit. We have knee clearance underneath the unit. It's not extending out past 18 or 20 inches, so we have 18.7 from the wall. Our pull rod would be well within our reach range, has to be under 48 inches, remember. Our shower head, 82 to 96 inches, and we have plenty of space in front of the equipment to allow for wheelchair accessibility. I have a couple best practices that I'm going to cover before we get into the Q&A section, and I'm going to tell you real quick about my survey program. But a couple things to keep in mind. One, remember that there needs to be adequate space around the emergency equipment for first aid responders. They need room to work on you after you exit the piece of emergency equipment. So make sure it's not really cramped, that there's plenty of space. They're going to have to probably put you on a gurney, stretcher, or something like that to remove you from the facility. So make sure that there's room around the equipment for after they exit the equipment. And make sure you're training employees on how to access and activate the emergency equipment. This is actually ANSI Z358.1, and is more of a bragging point. I like talking about this. This is color coding for emergency equipment. Red meaning danger, stop. Yellow is caution, tripping, falling, striking hazards. Orange is a warning and warns you of equipment points that may cut, crush, or otherwise injure. And then green, the color of a certain safety equipment manufacturer whose webinar you might be attending, is the location of safety equipment. So make sure you're holding true to ANSI hazard color coding as well. Remember the uses for emergency equipment: eye washes for wood shavings, dust, airborne particulates. Eye face washes are for minor incidents affecting only the eyes and face. Drench showers are realistically, they're only for PPE decontamination, personal protective equipment decontamination. You see those big suits that people wear, Tyvek, things like that. It's to remove those contaminants before you take the suit off. And then a combination unit is for chemical exposure. It's perfect for any situation. It's the most ideal type of equipment for any type of hazard. So exposure of the eyes, face, and body. The tepid water range, real quick, just wanted to touch on too cold and too hot. Remember that if it's too cold, you risk cold shock, cardiac arrest. The user may end the flushing before the recommended time and may not remove their clothing. So ensure that we are above 60 degrees, even 60 degrees, 70 degrees, that's still really cold. We like to focus on about 85 degrees as an ideal temperature for emergency equipment tepid water delivery. On the too hot scale, our average residential shower is about 105 degrees Fahrenheit. You would never like look up and put your eyes in your home shower, though. It's still going to be pretty hot. The Legionella bacteria growth chart and range also falls between 95 and 115 degrees Fahrenheit, which unfortunately dips into our ANSI range. So it's probably a measurement that's going to change in the future. I'm sure ANSI will lower the measurement, hopefully, to ensure that it's not falling within that Legionella growth range and not encouraging growth of that particular bacteria, because it can make things a lot worse. And then poll question number 3, Nicole, if you would, please.
Okay, would you be interested in learning more about tepid water solutions? Okay, thank you. And we just have a few more minutes of this presentation. We're going to go a couple minutes over, but if you could hang tight, we just have a couple of wrap up and follow-up slides.
Okay, a couple things to keep in mind. Number one, Remove your contacts when you get exposed to hazardous materials. They can trap it against your eyeball. Disrobe completely, including your socks and shoes. Many victims think that leaving the socks and shoes on is that they need to. You're usually standing on dirt, rocks, metal grating, but you need to remove those as well because contaminants can get trapped in your shoes. Provide privacy curtains. This is not your proudest day, and you need to be disrobed. So maybe give our coworkers a little bit of their decency back. Privacy curtains are a great way to do that on emergency equipment. We even tuck a little robe inside the pocket to be used with the equipment. Make sure if you're doing a high-risk task that you do bump tests. Ensure the equipment is working before you do whatever it is that you went into that area to do. And be cautious while assisting, not to contaminate yourself. If it's a coworker, yell and scream directions. Do not touch them, or you potentially expose yourself, making a situation even worse. Now, really quickly, this is a program that I work on specifically here myself at Haws. This is our ANSI Emergency Shower and Eyewash Survey Program. It's 100% free. It's complimentary. We will visit on site. I have trained staff all across the US and Canada. They can visit your site and inspect your emergency equipment, giving you a full day of inspections, an inspection report, an executive summary chart detailing, just like here on the right, what our compliance fines were, recommendations on how to fix those, a debriefing meeting and web conference with that person to help explain everything that we found. There are some restrictions, and that's really just comes down to if you have like one portable piece of equipment, we're not going to send somebody to inspect that. So make sure that there's you have plenty of equipment for us to inspect, and that we have to make sure that they're within a reasonable distance from you. So long as you meet those qualifications, we're happy to do a survey program for you. The pie chart on the right, that big Pac-Man size chunk of it is unfortunately the most common. This was based on an evaluation over 1,000 emergency pieces of equipment and is common. You have about a 1 in 5 chance that you're going to find a piece of emergency equipment that works the way it's supposed to and is going to deliver first aid, unfortunately. That is performance-related issues. Compliant, we found about 10% of equipment we actually find. The little blue size is just like missing a sign or there was an obstruction in the way. Not as serious as a performance-related issue, but again, 10% overall compliance is a pretty poor statistic. So please, you can sign up through our website or reach out to me directly. We're always happy to help you improve your on-site safety. Okay, and the last poll question, and then we'll get to the Q&A here in just a second.
All right. So Justin's gone through quite a bit of information, and it's definitely a lot to keep track of. And so based on all of this information, would you be interested in a free site survey of your existing emergency equipment for ANSI compliance? All right, give you just a few more seconds on this. All right, we'll give you just a second or two to wrap it up, and then we'll hopefully wrap the presentation and get you out of here. All right, and I'm going to go ahead and kick off this portion, and it is on our ANSI compliance services. It's a program that we provide here at Haws, and it's one of the most comprehensive offerings in the market today. And Justin sort of went into a little bit of detail on what our services team does, but we provide on-site evaluation and testing of your emergency eye, face wash, and showers against the ANSI Z358.1 requirements. And we have a a team of field experts across the nation that go out and actually work with facilities to make sure that they are meeting the requirements and ultimately just making sure that the equipment is available and ready in an emergency. And we deal with industries from manufacturing to healthcare, and we provide many service offerings, including the weekly and annual ANSI inspections. Those are very time intensive and resource intensive, and we provide staff that can actually come on site and do those for you. We work with facilities to provide preventative maintenance and contracts throughout the year. And as Justin again alluded to, we don't just give you a report on what's wrong. We will work with you to make sure that we can provide the repairs and or upgrades that are necessary to get you compliant and your emergency equipment up and working properly. We also do startup and commissioning, and we really, this goes hand in hand with our Haws integrated with our more complex booths that we provide. And then also to make sure that your team is understands what the ANSI requirements are, what the steps are to take to make sure that everything is properly running. We actually provide an online competent person training and certification course as well. So if you want to really get down and have your team trained, we can provide that as well. So that's just a quick overview on our Haws Services program. And I'm going to go ahead and kick off the last poll question. Okay, we are going to go ahead and wrap this up in just a second here. Get your votes in. All right. All right, and again, like I said, we had a lot of great, thorough questions throughout the presentation. So I think what we're going to do is really focus on providing you with a detailed response, and those responses will be sent out in the follow-up materials. I'm going to go ahead and answer some of the more basic questions, but again, be on the lookout for the follow-up materials for a more robust answer to any questions that you had. So the first question that we'll ask is, has the ANSI standard been adopted by OSHA?
No. The ANSI standard has not been adopted by OSHA. OSHA has their own standard, 29 CFR 1910.151C, and you thought I was reading off a slide, didn't you? I have it memorized. And that is their own standard. It's very frequently the case for OSHA to reference other standards to comply with their own. So there are probably no plans for that to become a permanent part of the OSHA standard.
Okay. Speaking of the ANSI standard, where can we get a hard copy on the ANSI standard?
You will have to go to their website. Our checklist is the closest thing that you can get for free, but they charge you for the ANSI standard through the ANSI website. You can go there and search Z358.1, and it will pull up the standard immediately. Pay to download it, and that copy is yours forever. But there will probably be, we get an update to the standard about every 5 to 8 years, and we're about due for a new one. So I'm sure the new standard will come out within the next year or two.
Okay, regarding testing, should eyewash and showers be run simultaneously during the weekly test?
Yes, absolutely. Use the bucket, activate the eyewash or the eye face wash, put the shower sock in place, the bucket in place, and activate the equipment. One of the most important things for us to discover during that test is simultaneous use issues. So start counting to 6, make sure that the eyewash or eye face wash doesn't dip out of compliance, and make sure that they're running at the same time so that we're getting an accurate read on a real life scenario, how much water the shower is going to output with the eyewash or the eye face wash running too.
Okay. And talking about the placement of the emergency equipment, you referenced 10 seconds. It should take you 10 seconds from the emergency to the eye or face wash station. What is that? How many feet is that roughly?
So that's why they gave us the addendum to the ANSI standard to ensure that we had a measurable distance. 10 seconds was confusing. Nobody understands completely why we got that first. 10 seconds, all of us can cover that distance in a different time. So it was important that we had something solid, something that we could measure, and 55 feet was that measurement. They gave us that in the addendum. We need to make sure that we measure from the eyewash to the hazard to ensure that it's within that 55-foot measurement.
Would you provide an example of a chemical that requires longer flushing? Is it a specific category of hazard or chemical structure?
More of a chemical structure. If I'm being honest, it's most corrosives that are about 30 minutes. Generally speaking, dust, particulates, bleach, Windex, those are like 15-minute flushes. If you look on your SDS sheets for almost any corrosive chemical, it's going to be about 30-minute flush time for those particular chemicals, because we have to make sure that it's off of your body before anybody else touches you, handles you, or we start removing you to the hospital. Otherwise, you're going to continue to get damaged and hurt the people trying to help you. So usually it's most corrosives that are longer than 15 minutes.
Okay, we'll go ahead and answer a couple more, and then again, the more complex questions we will be sending out in the documentation. Regarding penalties, what penalties would companies face if tests are not completed weekly and annually?
So one of the first things, first off, make sure that you're tracking those testings, whether it's a test card or a test tag on the piece of emergency equipment, or if you're doing it electronically, which is fantastic. If you have a program that you can use, track it that way. But one of the first things that an inspector, if they're there, if on their agenda is emergency first aid, showers, eye washes type equipment, one of the first things that they're going to ask for is testing records. They want to see that you are doing the due diligence. Even if it's only a couple months you've been doing, they want to see that you are actively doing this and participating and improving your health and safety culture and environment there at your facility. So ensure that they are you have adequate records. The type of fines that you're going to see are probably on the lower end if you're not seeing or doing weekly and annual inspections. Probably more severe for the annual inspection since it's a full performance evaluation. And if you're not doing them anyways, I mean, you run the potential for that inspector to find some things that you should have found initially, performance issues that are going to be dangerous for the victim, and things like that. So you're probably going to see them on the low side for like weekly activations and probably larger on annual inspections.
Great. In the slide, you show a maximum flow from the eye wash of 8 inches. Is there a minimum height of the stream of flow as well?
So 8 inches and under, it's not a maximum height that the actual water can spray from the eye wash or eye face wash. We just need to ensure that the eye wash gauge aligns under that 8 inches. So, and that's ensuring, again, that you're not trying to hover your face way above the eye wash or eye face wash, trying to align your eyes with the equipment. You can hold onto the bowl, get your eyes nice and close, and rinse them out. The actual flow from the eye wash or eye face wash cannot exceed 53 inches. But there is some funky equipment out there. Sometimes I really just tell people, evaluate your equipment, and if you've determined that it's injurious, there are ways to fix that and add flow controls and to fix those situations. So make sure you're paying attention to how, I mean, imagine your feet in the shoes of a victim and try to make the experience as comfortable as possible. But realistically, the water cannot exceed 53 inches, and we only use the gauge at 8 inches and below, making sure that it lines up, but the water can spray higher than that.
Okay, I think I'm going to wrap it up. But again, like I said, I want to be very clear that there were some really great questions that came through. So we'll be sending the responses out in the follow-up materials.
Okay, that's going to be it for us, for everybody. Thank you very much for your attendance. We really greatly appreciate it. Again, my name is Justin Dunn. I'm the product specialist and trainer. My information is on the screen. We have our customer service number up there as well. The follow-up email will be out to you as soon as we can possibly get that done. I'm going to answer all the questions. Nicole and I will tag team that and make sure we get it done for you, and include some other tools that will be really helpful for you. We will do another one of these webinars. We also do an ADA version of this. If anybody's interested, you can always sign up through our website. And again, stay safe out there, and we really appreciate your attendance, and have a great day.